This example shows you the how to import a spice model from a device and using in the Zener spice simulation. So first you have to go to tools and create new microresult and type the diode model that you are importing. And you have to select the spice model from the downloaded file. Yeah, I have downloaded to my computer, and you can import it from anywhere where you have downloaded. So I have opened, selected this spice model, and then go next. And since this is not shape of Zener diode, I'm selecting the proper diode and untick this one. And use from diodes, I can pick this exact Zener diode model. This one will be looks like this, and here you can see number 1 is for anode and number 2 is for cathode. So I'm connecting 1 to here and 2 to the cathode, and that will create my model. So I have to select it here. Since I have already installed this one, I just insert it. So you can use Control R to rotate this one. Okay, so I'm going to insert the battery and the series resistor and the load. And in order to make the simulation correct, I have to insert a ground. So to measure the output voltage, I'm using a voltage meter. To measure the input current, Zener current, I'm using an ammeter. Another ammeter to find the measure the load current, and one last ammeter to find the source current. So using the wire tool, I'm connecting all the wires. You can label the ammeters and voltmeters based on the correct name, whatever the name that you prefer. So the calculated resistance is 320 ohms. Okay, now our circuit is completed. We have used the 1K resistor as the load, and we can change the battery voltage to 12 volts, the rated value. Okay, so now we just need to simulate it. Go to analysis, transient, and use the time span could be 10 seconds. Simulation time, and use the 0 initial values because we are starting the circuit from the 0 values. Okay. Then run it and go to view, separate curves. From here you can see the output voltage. Now using these cursors we can find this output voltage. So that is around 5.88 volts, and the Zener current is around 13.25 milliamps, and the current through the series resistor is about 19.13. That's the summation of the Zener current as well as the load current. Okay, now if you want to change this battery voltage, and you have to redo it again. So change to battery voltage, and if you want to change this output load, you can change these parameters and go to analysis, transient, and redo the simulation, and from view, separate outputs, you can take this one. So based on the simulation results, now you can work on the load and line regulation. And the last thing is finding the behavior of the regulator for input noise. In this example, I'm using a voltage generator. That is VG1. So the input noise is sinusoidal and peak-to-peak ripple of 300 millivolts, and the frequency is 500 K. Okay, so I can see what is the, when I'm inserting a noise into the source. That could be basically when you're driving these automotive vehicles, this battery is connected to different other power supplies, switch mode power supplies, the generating noise. That noise is coupled via this battery positive terminals to the rest of the other circuits. So in this example, if there's a noise coming from other power supplies which are connected to the battery, we can observe what is the output voltage looks like. So I'm going to run this transient. I'm just reducing the time span for 1 millisecond. And okay. Go to view, separate curves, and you can zoom it up a bit like this. And this is my output voltage. Right. So when you're applying a 300 millivolt ripple at the input, your output voltage will be peak-to-peak ripple. So this is a DC voltage, so you just need to find the peak-to-peak ripple. It is around like 49.85 millivolts of ripple at the output. So for 600 peak-to-peak ripple, you will get around 50 millivolts peak-to-peak ripple at the output.